and welcome to a new video. In this video we are going to solve some exercise about complex numbers. Okay, so the first exercise, we have basically this complex number, let's call it z, which is 3 minus 3i, where I obviously is the imaginary unit, and we have to find the modulus or the absolute value of z. Okay, so we can also draw z as a vector or a point on a plane where basically we have the vertical and the horizontal axis, and here basically on the imaginary plane the horizontal axis is the real axis, where basically we have to represent the real part of the numbers, and the vertical axis is the imaginary axis. Okay, so if z is 3 minus 3i, it means that basically the real part of z is 3 and the imaginary part of the number is minus 3. So here basically we have that the real part is 3, so 1, 2 and 3, and then we have minus 3. So the number is basically, here we can represent the complex number as a point in the complex plane, or with a vector, so we can draw also vector. Okay, so here we have the number, and if we want to basically find the absolute value and the angle of this number, so the absolute value is basically the length of this vector, and the argument is this angle that we can call theta. Okay, so the modulus, the absolute value of our complex number, is basically given by the Pythagoras rule, the Pythagoras theorem, where we have to consider 3 squared, so the real part squared, plus minus 3 squared, so the imaginary part squared, all under square root. So here basically we get 9 plus 9 under square root, which is 18 under square root, and we know that 18 is 9 times 2, so we can write 3 times the square root of 2. Okay, so this is basically the absolute value of z, of our complex number. And then as far as the argument is concerned, so the angle theta is concerned, we already know basically that theta here is 45 degrees, but with a minus, because here the vector is pointing basically downwards. But if we want to calculate it, we basically have to consider theta as the inverse tangent of minus 3 over 3. Okay, so from here we have tangent to the minus 1 of minus 1, but we know that of degrees, or if we want, we can also write minus pi fourth. Okay, so minus pi over 4. Okay, so we basically found the absolute value of the number and the angle, so the argument. So this means that basically z, which was 3 minus 3i, can also be written as 3 times 2 under square root, so the absolute value of the number, times e to the minus I pi fourth. Okay, so this basically is the complex notation for the complex numbers, where here we have the absolute value and here we have the angle, or the argument of the number. Okay, in the second exercise we have basically to consider a division between two complex numbers. So the first complex number, the numerator is 2 plus I over 1 minus 3 times I. Okay, so we have to consider this division, and we have this ratio, and we have to calculate it. And to do so, the idea here is basically to multiply and divide this ratio by the complex conjugate of the denominator. So we can draw here a line, and then we have to write here and here the complex conjugator of this number, which is basically this number, but here we have to basically change the sign of the imaginary part. So complex conjugate is basically 1 plus 3i, and also here 1 plus 3i. Okay, so the complex conjugate is basically this number, except for this imaginary part, which has a changed sign. Okay, so we did this, so now we have to consider this multiplication. So basically, as numerator we have 2 plus I times 1 plus 3i, and then here as denominator we have to consider this multiplication between this number and its complex conjugate. But we know that here we basically get 1 plus 9, because here we have minus and here we have plus. So basically this multiplication would give us the square of this number minus this number squared. But we know that 3i squared is minus 9, so here we get a plus. Okay, so we have also to consider this multiplication. So here we get 2 times 1, which is 2, and then we have plus 6i plus I, and then we have minus 3 from this multiplication over 10. Okay. Okay, so here we get 2 minus 3, which is minus 1, and then we have plus 7i over 10. Okay, so basically we are done with this exercise, or if you want, we can also write minus 1 over 10 plus 7 over 10 I. Okay, so this is the real part, and this is the imaginary part of our result. As the exercise, we basically have to calculate the value of 1 plus plus I, all raised to the power of 8. Okay, so here basically we have to find the value of this complex number, and to do so it is convenient to basically write this number, so the number 1 plus I, considering the sine and the cosine function. So the idea here is to consider the absolute value of this number, which is 2 under square root, because the real and the imaginary part of the number are both 1, so the absolute value is 2 under square root. And then we have to consider the cosine of the argument, which is pi fourth, plus sine of the argument, which is pi fourth again. Okay, and times I, obviously, here. Okay. Okay, so we basically wrote in another form our complex number, because now if we consider this operation, so we have to basically raise this number to the power of 8. But if we do so, we have to consider this number. If we do so, we have basically 2 under square root raised to the power of 8, and we basically have cosine of pi fourth plus I times sine of pi fourth raised to the power of 8. Okay, and we know that this number is 16, because here we basically have 2 raised to the power of 4, so 16. And then as far as this value is concerned, we can consider a theorem which is called the Moivre theorem, and here basically we can write that cosine plus I sine of pi fourth raised to the power of 8 basically becomes cosine of 8 times the argument plus I times sine of 8 times again the argument. Okay, so basically here we used the exponent here, so 8, the exponent 8, and basically 8 goes here in the argument of the cosine and the sine, and we have to consider the multiplication between the exponent and the argument of our number. Okay, so here basically we get 16 times cosine of 2 pi plus I times sine of 2 pi, and then we have we know that the cosine of 2 pi is just 1, and then the sine of 2 pi is 0, so we basically get I times 0, which is 0 obviously, and then because of this we get just 16, which is the final result. So we basically proved that this number is equal to 16.